Welcome back. In this video we're going to finish up the Chapter 8 practice problems. So we've already talked about alkanes and alkenes in the first video. In this video we've got our third hydrocarbon, which are the alkynes. So now we are looking at a Y in the name. Alkynes are hydrocarbons that have at least one carbon-carbon triple bond somewhere in the molecule. Just like with the alkanes and alkenes, we have a general formula that relates the number of carbons to the number of hydrogens. So if you know the number of carbons, this time hydrogens are going to be 2n minus 2. So the alkanes, if we remember, were CnH2n plus 2. Alkenes were CnH2n, and now we are down to CnH2n minus 2. Notice each step going from alkane to alkene, we lose 2 hydrogens, and alkene to alkyne, we lose another 2 hydrogens. That is because every time we add an extra bond between carbons, we have to remove 2 hydrogens to do so. So you've got the same examples as we did with the other alkanes and alkenes. 6 carbon atoms, take that times 2, now we're going to subtract 2, so we have 10 hydrogen atoms. Here we know 2n minus 2 must equal 8. So in this case, the n must be 5. For 9 carbons, 9 times 2 minus 2 is 16. And then the last example, we know 2n minus 2 equals 32. So the n must be 17. For drawing alkynes, it's very similar to alkenes, except now you're going to put a triple bond somewhere instead of the double bond. Again, at this point, it does not matter where you put that triple bond. So for C6H10, this example, I'm going to put it on the end. Again, you can put it anywhere. This carbon already has 3 bonds, so it only needs 1 hydrogen. If I look at this carbon, it already has 4 bonds, so it will have 0 hydrogens. The next 3, working right to left, all need 2 hydrogens. And then the one on the end will need 3. So again, the goal here is to give all carbon atoms 4 bonds. Next one, we've got 4 carbons. This time I'm going to put the triple bond in the middle. So if I look at the carbon on the left, it currently has 1 bond. So I'm going to give it 3 hydrogens. The 2 in the middle already have 4 bonds, so they have no hydrogens. And then the one on the right also needs 3 hydrogens. So there are the 6 hydrogens that we have in our formula. Go ahead and pause the video and see if you can draw an alkyne with 5 carbons. So for 5 carbons, again, put your triple bond anywhere. Yours could be in a different spot. Fill in your hydrogens so that all carbons have 4 bonds. And in doing so, you will find that you used 8 hydrogens, and that makes sense because if we use our formula, we have C5H8, 2n minus 2. For physical properties of alkynes, again, we're going to relate boiling point. We've already talked about alkanes and alkenes. Here, the alkyne is going to have a slightly higher boiling point than the alkane. And here, this is because it is straighter. So if we think about the structure of an alkyne, that carbon-carbon triple bond, just make the simplest option here, is linear. It's 180 degrees. So that makes the molecules relatively flat and they can stack together even better. So here's our overall ranking. Highest, and this is true for boiling point and melting point. Alkenes are going to be the lowest, alkanes are in the middle, and alkynes are going to be the highest. Also remember, for alkenes, your cis double bonds are going to be lower than your trans double bonds. Where we're going to rank our boiling points. So we're given formulas, which means we first need to decide if they are alkanes, alkenes, or alkynes, and we do that by using those general formulas. So remember, we had the 2n plus 2 for the alkanes, 2n for the alkenes, and 2n minus 2 for the alkynes. And then for our boiling point ranking, the alkenes are the lowest, alkanes are in the middle, and alkynes are the highest. And then we also have our cis versus trans, but in this case, we don't know cis and trans, so we're just going to be looking at the main alkene. So to get from 5 to 10, that is the 2N, which makes it an alkene. 5 to 12 is 2N plus 2, so that's an alkane. 5 to 8 is going to be 2N minus 2, so that's the alkyne. So now if we just rank these, the alkyne is going to be the highest, and the alkene is going to be the lowest. Go ahead and try this last example. See if you can figure out what is the alkane, alkene, and alkyne, and then rank the boiling points. All right, 8 to 18 is 2N plus 2, so that's the alkane. 8 to 14 is 2N minus 2, that's the alkene. 8 to 16 is, sorry, this is alkyne. 8 to 16 is 2N, so that's the alkene. So we have the highest and lowest. Next sets of problems, we're dealing with drawing structures. So we've got several different ways. We've got structural formulas where everything is drawn out, and we have condensed structural formulas where we do not show the carbon-hydrogen bonds. So to go from your full structural formula to condensed, work your way down the main backbone, carbon to carbon, and then write how many hydrogens are on that carbon. So if I look at the first carbon, there's 3 hydrogens. If I look at the second carbon, there's 2 hydrogens. If I look at the third carbon, there's 1 hydrogen, but then I also have this CH3 group. So if it's coming off of the main chain, you're going to put that group in parentheses. Now I'll go back up to the main chain. This carbon has 1 hydrogen, and then it also has the CH3 group. Put that in parentheses. Next carbon has 2 hydrogens, and then the one on the far right has 3. The next example goes the other direction. So first carbon has 3 hydrogens. Second carbon has 2. Next carbon has 1, and then remember anything in parentheses is a branch coming off of that previous carbon. So CH2, CH3. Now we're back out of parentheses, so back to the main chain, CH. Then it has a CH3 branched. Back to the main chain, CH3 for the other end. So again, we've got our full structural formula and our condensed structural formula. Here's another set of examples where you're given the full structures. We want to draw them as condensed, which we've already done, and then line angle. So go ahead and pause the video and see if you can draw the condensed structures first, and then we will come back and I will explain the line angle. So for condensed, we've got CH3, CH2, CH, and then this group is going to be in parentheses, CH2, CH3. Next carbon is a CH with a CH3 in parentheses, and then a CH3 on the end. Condensed for the one on the right, we've got CH3, CH2, CH with a CH2, CH3 in parentheses, CH2, CH. This is going to be in parentheses. I'm going to have to break my line here. So that's a CH3, and then a CH3 on the end. For line angle is where you're going to use lines at angles to represent your carbons and the rest of your molecule. So the end of each line is a carbon. Anywhere your line comes to a point is a carbon. You do not draw in hydrogens. If you're going to count hydrogens, you assume carbon has 4 bonds, which it always does. So you would add in to where you get 4. So this carbon already has 1 bond, so it's missing 3 hydrogens. This carbon has 2 bonds, so it must have 2 hydrogens. This carbon has 2 bonds, so it must have 2 hydrogens. This carbon only has one bond, so it must have 3 hydrogens. So if we do the molecule on the left, we have 1, 2, 3, 4, 5 carbons. So remember, when you put your pencil down, that's carbon 1. So 1, 2, 3, 4, 5. The third carbon over has the 2 carbons coming off of it. So here's my third carbon. So I'm going to go 1, 2. The next carbon over has 1 carbon. So here's the 1, 2, 3, 4, 5 across the main chain, a branch of 2, and the single carbon. For the next example, we have 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. The third carbon over has 2 carbons. So 1, 2, 3, we're right here. We've got 1, 2. Notice the up and down doesn't matter. Then we've got 3, 4. So the second to last from the end has a single carbon.